Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Rezain Abbas+Mohammed and my other team member Muhammad Raad. Microstructure-based analysis of the residual stress concentration and plastic strain localization followed by friction in metal matrix composites. Introduction. Stress concentration, plastic strain localization and consequent location of microscopic cracks and defects in a material are all controlled by interfaces between microstructure components. The differences in mechanical properties of the contacting materials influence the value of local stresses and strain concentrating around the interfaces. As is well known in the context, microscopic stress strain analysis is critical in the development and research of composites with a wide range of interfaces between structure parts with clearly unique properties. One, research area and application. Metal matrix composites, MMCs, which were first described as important materials advanced in the last 20 years in 1994, have just recently become mainstream in the aerospace and automotive industries. Particle reinforced composites are widely used in the coating industry. The hardness, abrasion, and resistance to corrosion of compound surface layer can all be improved by particle reinforced composites. One, problem and issue from an initial underformed state to state achieved after cooling from the recrystallization temperature to temperature that are C6061 T6 MMC unit cell underwent diverse from of tensile and compressive loading. The differential in temperature increasing of carbon and aluminum causes residual stress in the mixture as consequence of cooling. One, methodology framework for computer-aided design of composite material. In the main objective of this research, the step-by-step packing SSP approach to use the great microstructure models on regular meshes with a range of geometrical properties. The SSP approach is based on the following concept: a computational mesh, an X and Y and Z made of cubic components of the same size, discretize the material volume to be investigated. Can you complete, Muhammad?
Thank you, Rezain. This is Muhammad Raad. The mathematical method for microstructure element step-by-step packing approach was modified by the authors by combining the application of SL and NSL growth laws. Computational approach was developed for creating a polycrystalline metal matrix ceramic particle composite, which enables the creating of 3D microstructure with various ratios of polycrystalline average grain size to particle size. The dynamic approach solved boundary value issues, such as the momentum equation equilibrium model, as well as a strain rate relation. Here in this relation, we have rho is the mass density, where U is the displacement vector, the comma in the notations, and the superposed dot denote the space and material derivatives respectively. The local matrix region is assumed to fail if the equivalent plastic strain reaches a limiting value, where here we have equivalent plastic is ultimate strain. An isotropic elastic brittle solid is used to approximate the thermomechanical response of a ceramic particle. Here we have the K and Mo are bulk and shear model correspondingly, and the Einstein notation is used for repeated indices. For analysis of ceramic particle cracking, energetic criterion of the Haber type that takes into consideration crack nucleation in local regions experiencing tensile stresses was employed as follows. The stress of the equivalent equal to stress tensile. If equivalent more than zero, where stress tensile is ultimate tensile strength. As soon as the condition is fulfilled, crack of local area, either in a matrix or in a particle mean the following. If the selection is found below the situation of bulk tension equivalent more than zero, all stress tensor part set to zero. When the area experiences compression equivalent less than zero, the matrix material resists everything but shear. One of the primary difficulties in solid state physics and solid mechanics is determining the plastic strain rate tensor. Contribution of research article. Thermomechanical deformation and fracture of the particle reinforced zirconium carbide aluminum 6061 composite, where examined numerically a computational approach for generation a three-dimensional composite microstructure using a metal matrix with a polycrystalline structure, and a complicated shaped ceramic particle has been created. Models for an anisotropic elastic plastic response of grain in a polycrystalline aluminum alloy matrix and isotropic elastic brittle behavior of zirconium carbide have been created. The conclusion: because of the complicated structure of particles, localized area of bulk tension arise during compression of metal matrix composites. Local tensile regions from different places during compression of tension of the composite, and tensile cracks from when the composite is stretched or compressed further. Tensile cracks propagate in plane perpendicular to tensile direction of the composite but parallel to the compression direction. That's all. Thank you very much for listening.